Hello, everybody. How are y'all doing today? Nobody asked or has the ability to right now, but I'm doing splendidly. My name is Tim Sylvia. I'm an editor with PV Magazine USA, and I will be your moderator for today's webinar, High Density Ground Mount Racking Solution with Significant Capital Expenditure Savings for a Lower Levelized Cost of Energy. Joining me today is an all-star cast of presenters, Nir Deckel, Vice President of Business Development with Jurchen Technology, and Herman Haloza, EPC Manager with Volta Solar. I know that they're both chomping at the bit to get to their presentation, and I would be too if I was them, and we have a lot to go over today, so I'll try my best to keep this next part pretty brief. Before we hop into the presentation, we have a little bit of housekeeping to take care of. This webinar will be comprised of a roughly 30-minute presentation, followed by a question and answer session for the remainder of the time. However, you are free to submit questions at any point during the presentation. Due to time constraints, we may not have time to address every single question, but we will certainly attempt to. With this webinar, we think we'll be able to answer more than with others. If you have any technical difficulties during the webinar, try exiting and rejoining. If problems persist, shoot us a message and we will work to resolve it. In addition to myself, my colleague Frederica is waiting in the wings to assist with any difficulties. Okay, I believe that just about does it for all of our housekeeping. So let's switch our focus back to the topic at hand, the PEG racking system. If any of you are consistent readers of PV Magazine, you may have already been introduced to the system by some of our previous coverage. It's a system that I'm familiar with and I am excited to have this webinar on. So I know there's loads more to the system and I know that our presenters want to share that with you. So with that in mind, I'm going to hand it over to Nir and Herman to take us on an exploration of the PEG racking system. Guys, the floor is yours.
Good morning, good afternoon, everyone. My name is Nir Deckel, VP Business Development at Jurchen Technology. During this presentation, I will present you the system that you can now see on the screen, the PEG racking system. I would start with a short introduction about the company, Jurchen Technology. I would then discuss the benefit of the system, probably the most interesting part of this presentation. Then I will discuss the design aspect of that system, the installation, maintenance. Then we'll discuss a bit about the bankability of that system, global experience, and then a short summary of all the topics that will be discussed today. So first about Jurchen Technology. The company is in the solar business for more than 12 years by now, based in Germany, focusing on designing, manufacturing, and selling solar racking system and DC cabling system. As you can see, so far to date, we've sold more than 2.6 gigawatt of racking system and more than 3 gigawatt of cabling system. In the photos in this image, you can see a few of the interesting latest sales that we've had, cabling for 349 megawatt system in Australia, and relevant to the presentation, to the PEG system today, the close to 11 megawatt PEG racking system sale to Australia. Just in short about the main product that Jurchen Technology sells. First one is the PEG system that I will discuss today. There are other type of substructure, uni-base, twin-base, for different application, different slopes. And DC cabling harnesses, which are specially designed for a project, connecting few strings into one. This system, by the way, will not be discussed today, but it will also be UL certified together with the PEG, which is already UL certified. Our cabling system will be UL 2703 certified by the end of the year. And we're also selling cabling for floating PV, as you can see in this image. Now let's start about the PEG. Before we drill into the detail how this racking system looks like, let's talk about the benefit of that system. The PEG offer by far the most extreme land use more than any other system. In terms of comparison per acre, the system produces around 225, between 215 to 240, depending on the location, 240% more yield versus tracker and other fixed system per acre. and 3 times more DC capacity for a given size per acre compared to tracker and fixed tilt system. The system is extremely cost effective in few aspects: the supply of the substructure, the freight of the substructure, which is much more cost effective than others, and also regarding a lot of aspects of the installation that I will discuss later on. The system is very low, around less than 3.3 feet above ground and around 2.5 feet below ground. So low profile, low foundation. The system is very light, around 28 pounds per kilowatt peak, assuming 400 watt modules, by far lighter than any other substructure. And the system is already installed globally for over 200, actually over 210 megawatt of project worldwide. In the photos here, what you can see is basically related to the bullet number 1 in this slide. You can see how compact the system is. Just an ocean of panel with very minimal gaps in between. So the land cover ratio is almost the maximum possible. A bit more about the land use, where it's coming from, how it can be so high, so effective, high versus racking system and other fixed system. In this example, in this slide, you can see a certain site. In this case, this is a farming land in Australia. On the same land, you can see here PEG and a tracker system, a layout for both. In the PEG example, you can see around 20.5 megawatt peak system. And with tracker, you can see around 7 megawatt system, both, of course, using exactly the same modules, in this case, 400 watt modules. And the reason for that difference, which is almost 3 times more PEG versus tracker, is explained in the sketch below the layout. What you can see in the left side is a PEG system block of typically around between 36 to 38 module wide, up to 130 feet wide. And then there's a gap of around 3.3 feet. We keep 1 meter gap in between for O&M personnel to walk between the blocks. And then the next block start. So basically the land cover ratio is almost 100%. It's around 96, 98% of the land covered with modules. And if you look at the tracker, this picture is quite different. For every, let's say, around 7 feet of a module, there's around 10 feet of a gap, which is required for shading perspective and also for installation machinery to drive in between. So far less land use with tracker or other fixed system versus the PEG. This is where the difference is coming from. Let's talk a bit about the design, how the system, how the racking system looks like. Basically, there's no racking system. That's the story in short. The modules are there are 4, basically let's call them 4 legs under the corners of the modules, and each of those legs is made of steel rod, which is rammed into the ground. You can see here in the image at the right side, a ground plate which is crimped into the road, a top plate which is also crimped into the road, and on top of the top plate you will find 4 modules on top, which are clamped with using 4 clamps. So that's basically what the substructure looks like. This combination of 3 items is one of those legs. The modules are 8 degrees tilted east and west. As an option to deal with very soft soil or where shallow foundation are required, for example, because of a very high water table under the ground, we have a special solution, a special rod called the anchor rod, which is not rammed into the ground, but drilled into the ground to a depth of around 1.5, 1.6 feet. And later on, Herman, one of our customers, will mention this anchor rod because this is extensively used in a project in the Netherlands. The PEG system is already certified for UL 2703, which is the grounding and bonding, already done from January this year. And again, in this sketch, you can see the system above ground height, which is around 1 meter, around 3.3, 3.4 feet, and below ground, typically 2.5, 2.7 feet below ground, subject to the ground condition and the site and the wind speed for the specific site. A short note about a special design that we have developed recently for the PEG, which is called high load design, which is dedicated for site with wind load of more than 25 or 30 PSF. In this specific design, there is an additional rod and plate under the middle of the long edges of the module. Without a clamp, there's no clamp attached to it. The module just sit on this rod to withstand the snow load. So this is relevant for sites more than 25 or 30 PSF, subject to the engineering work calculation done per site. This solution is very suitable to project in Northeast USA, up to 60 PSF and around 130 miles per hour wind. There are already few companies looking at the PEG for project on this site, and probably the first system will be installed later this year, a pilot system that will be installed in New York. Another very interesting aspect of the engineering that was done lately for a few of those projects basically concluded that the foundation, the depth of the rod, is unaffected by the frost. And the reason for that is that the rod is very thin. It doesn't allow the frost a grip on the rod and doesn't allow the frost to apply upward load on the rod. So that's a very positive conclusion that we have made recently, which basically means that the depth of running expected for the rod, the PEG system in Northeast USA is not different than the standard, around 2.5, 3 feet underground, not more than this, while with other systems, you need to go way, way deeper, probably around 50 inches below the depth of the frost. So that's another huge advantage of the usage of PEG on snow sites or sites when there's frost soil. The first PEG project for this high snow load design was actually installed 3 weeks ago. 4 weeks ago was commissioned in Austria, in the Alps, for a site which is 55 PSF snow load. So this solution is not only, this design is not only concluded, but also implemented and built on a commercial project. Another short note regarding the PEG design, this time for a First Solar Series 6. This solution, PEG with First Solar Series 6, will be introduced into the market by the end of 2020. We are now at the very last stages of the design and engineering part of that system, to be followed soon by UL 2703 compliance, 2703 application. This solution is based on a special top plate that you can see here, basically similar top plate of the PEG that I've shown before, and a very unique, a very innovative clamping system developed by a French company called Aramont, where the module is just sort of clamped into the plate without any tool, just by applying a bit of a force. And then to unlock it, basically you need a plier to release that. So that's a very, very innovative design coming up very soon and available by the end of this year. A bit about the strengths of the system. First question people typically ask when they are being presented with the PEG system is the system robust enough to withstand different conditions, wind conditions, snow conditions, etc.? Well, the answer, very simple, is yes. Earlier this year, we've completed actually a second wind tunnel test. The first one was done a few years ago. The second one was done earlier this year by IFI in Germany, one of the most reputable engineering firm in Germany. Here in the image at the left side, you can see the model, the 3D model that was developed for those tests. Following those tests, the PEG system was officially certified to up to 160 miles per hour wind based on ASCII 7.10. Those tests were done to both European standard, a US standard, ASCII standard, as well as other standards like the Australian. Even before those tests were done, actually the PEG was already compliant to a tropical region with high wind speed, like Wind Region C in Australia, made by a local engineering company in Australia for wind up to 150, 160 miles per hour. I will just note that the official figures up to 150 miles per hour. However, we do look at sites of up to 170 and a bit more, 170 miles per hour. Those sites require the same PEG high snow load design that I've shown before, with the only difference is that additional clamp is added to the additional plates. We're about to run through engineering calculation for those sites. That will very likely be end up successfully. So the PEG would actually be officially be available for sites up to 170 or even 180 miles per hour. And by the way, the reason for that is that the PEG is very low, 1 meter above ground. And the wind force that is applied on such a low height above ground is far less than higher than 1 meter. And the second reason is the fact that the modules are tilted only at 8 degrees, which is very low angle. So the wind doesn't have the grip that it has on the substructure as it does with tracker system or other fixed system. Next is a bit about the installation process. The first thing I would say that the term construction is an overkill for PEG. It's completely irrelevant. In a construction process, you imagine a heavy machinery for drilling, for concreting, for trenching, to lift heavy substructure equipment, as you can see here at the photos at the top. Those are completely irrelevant for PEG. A PEG installation site looks like a farming activity rather than a construction process, which is why we came up with the terminology EPI. EPI instead of construction, installation. And why is that? Because the PEG installation requires far less material, far less labor, doesn't require any heavy machinery other than forklift basically to lift the pallets of the substructure and the modules. There's no trenching, there's no concreting, everything is above ground, including the DC cabling, which is attached to the substructure. The working height is around 3 feet, so comfortably done from the ground level. And the heaviest tracking system item is around less than 7 pounds. So all those substructure items can easily be carried by hand. So which is why construction is completely irrelevant. EPI is the right terminology that we apply for PEG. And all this that is presented in this slide clearly implies huge amount of saving related to the CAPEX into the installation of the PEG system. So just a bit more about the installation. So there are 3 main stages. You can see here photos from a small pilot system that were installed in different countries. So the first stage is the ramming of the rod into the ground. Second is the crimping of the ground plate and the top plate. And third is the module mounting. So the PEG system is extremely fast, very safe, and very simple system to install. What we see with Project Worldwide is actually even closer to 0.7 man-hour per kilowatt peak, or around 700, a bit more than 700 man-hour per megawatt peak for all labor required for the DC installation. What we see with Project Worldwide that are only 5, 6, 7 megawatt each is that the installation progress per week is 1 megawatt or a bit more per week. 2-3 days is all which is required for the labor on site to be at full speed. So 7 megawatt project in Australia were built in 7 weeks, by far faster than other installation. Of course, this has other cost implication related to the operation of the site. Let's talk a bit about O&M. How the PEG system is maintained. First is about cleaning. We came up with a very simple and cost-effective way to clean the system. We call it the galley-in system, which is this rectangle-shaped structure or V-shaped structure with an axis in the middle and a brush underneath the structure, which is only 40 pounds in weight, being pulled from one side and then pulled by the O&M personnel from the other side. So basically cleaning 2 rows of module in one shot. It is already in use in Germany, Australia, and Israel, and we see around 250 modules being cleaned every man hour for 1 man hour. This is around 20% faster than what our customers see with other cleaning of others' racking system. And the reason is that with the PEG, each block has more than 500 modules. So one block with 500 modules is cleaned very fast in one shot, rather than while with other system, the O&M team have to move their equipment over a large number of much smaller tables, much smaller mechanical blocks. So the efficiency of the work is far greater with PEG versus other system. I would just mention that we look at few robotic systems to be available for the PEG. So the robotic system will basically drive autonomously on the structure and clean the modules. We've already tested one successfully, and we assume that it will be at least one solution will be available in the market during next year. Second topic is the access to the DC plant. The access to this plant is done from underneath. The height of the system, which is around 3.3 feet, the lowest part around 4 feet, the highest part, allow a relatively easy access underneath the system, as you can see here in the photo in the middle. Some customers use trolley, like the one you see in this image, the second from left, to lay on their back and to drive themselves underneath the system. Actually, one customer have a similar trolley with a motor. So a motor will help you to drive underneath the system. With regard to access to site, what we see is that customer telling us that the physical access to site for inspection will not be done more than once a year, while most other inspection that will be done during the year will be done using drones, which will become more and more popular for solar plant and is very suitable for the PEG system. The third topic I want to mention in this page is vegetation control. There are different methodologies that were implemented for vegetation control in PEG project worldwide. The most successful one is what you see in those two images. This is a fabric sheet, basically made of polypropylene geotextile, which is industrial, which is used by industrial application quite extensively. It is strong enough to avoid vegetation from growing. On the other hand, it is not flammable, and it allows water to penetrate through that. That system photo, in the middle is a photo taken from a solar plant in north part of Israel, 14 months after installation. While there's a lot of vegetation all around the PEG system, but underneath you see that there's nothing. And the local O&M team are extremely happy with the fact that they have decided to implement this solution. Another solution is a mowing robot that you can see here at the photo at the right side. This system is already in productive use in Germany by our parent company, especially made for PEG. And at the moment, we are looking at other robotic systems which are based on commercially viable machines that are used for private use at the moment, and those will drive underneath the system autonomously as well to cut the grass. So we're about to run a few tests, and we are optimistic that more other options of robotic mowing machine will be available. Some customers are evaluating the use of clover grass, which is a very dense and low profile grass that grows to a height of less than 10 inches and doesn't allow any other vegetation to grow. This solution was not yet implemented, but we have customers in Europe that are closely looking at this solution. The use of chemical and crusher dust were used by few customers worldwide, especially in Australia, and those are of course also our additional methodologies to deal with vegetation under the PEG system. Next slide. Sorry. Next slide is about bankability. The PEG system is actually bankable from a few years back. Two projects were provided depth finance by two of the three large banks in Australia. One was pre-construction, one was post-construction. 2 months ago, we have released a bankability report for PEG made by DNVGL that I'm sure you're all aware of. This report deals with the company itself, Jurchen Technology, the manufacturing of the PEG system, different aspects of the design, the installation, the O&M of the PEG system, as well as performance and land use, as you can see here at the right side. Here, what you can see, a comparison of PEG versus tracker and fixed tilt in different locations in the US. You can see the same number that I mentioned before, around 225% more yield with PEG versus other system. And you can see here below the comparison of ground cover ratio, around 1 with PEG and far less with other systems. This report, by the way, is available upon request. Next is a bit about the global presence and project already implemented with PEG. So we just crossed the 210 megawatt worldwide. You can see here projects all over the world, in Australia, in Europe, in Asia, Africa, also one in South America. We don't have yet one in US, but we are getting close, very close to that. So what you can see, the PEG is implemented in a project as small as few tens of kilowatts, few hundreds of kilowatts, and up to 11 megawatt project, which is today the largest single site PEG project. It will not remain that for long. In 3 months, a 20 megawatt project will be built in Asia. That will become the largest so far. In the next slide, I want to tell you a bit about 4 case studies for PEG. And each one I will describe different aspects why the PEG was so successful and beneficial for the customer for this specific project. I will start with Goondiwindi in Queensland, Australia, 4.8 megawatt project that was commissioned in 2017. What is so interesting with this project is that at the same time this project was built and commissioned, there were around more than 20 projects in Australia that were provided direct government funding of up to 40%, 45% for those projects to be commissioned. The PEG was not provided even 1 cent by the government, but still there was a developer and an installer and a customer who believed in the system and decided to implement that without any direct government funding. It was commercially viable already back then, while in parallel many trackers and other racking systems were built with large amount of government funds. So this was the first global proof for the benefit of the PEG system, for the low CAPEX of the PEG system, and a competitive LCOE. Second is Jurchen in New South Wales in Australia. This is actually a project that I've developed myself when I lived in Australia, around the 3.7 megawatt peak. What was so interesting in this project that it is located in a beautiful winery area in Australia, a farming land, surrounded by properties. Few of the neighbors initially objected to solar plant being built next to their property. However, they quickly removed their objection once they saw what's the application, what's the system looks like, how the racking system looks like. Only 1 meter above ground, they barely see the system, they will barely hear noise during installation, and they were quick to remove their objection. So this was another very nice proof of the value of the PEG related to the system being environmental friendly, low profile, barely visible. So this is what had happened in that project. The third one is Mesilot, project in north part of Israel, 4.6 megawatt peak that was commissioned around 14 months ago in the spring last year. The land was very tight, as you can see here in this layout. The PEG was the only solution that could be implemented implemented in that project to allow the project to be basically viable, financially viable. And this is clearly, this process repeats itself in quite a few other projects worldwide, where the extremely high land use of the PEG was key value to allow the customer to implement the project. And what we get from developers worldwide, that for exact same reason, the PEG open up a huge amount of opportunities for land search during project development, which otherwise would absolutely not be possible because of the land being so small. The fourth one is Barcaldine in Queensland, Australia, the 10.8 megawatt project. What was interesting in this project that during the same time that the system was installed, there were other projects that were installed in Australia with a few injuries, even 1 or 2 fatal injuries. The Queensland government arrived to site unexpectedly to do unscheduled audits, and the inspector was fascinated, provided extremely positive feedback and indicated that the installation of the PEG system is exceptional. He didn't see any health and safety issue other than blisters and dehydration from the heat. And actually, he agreed for us to publish a case study for this, and a nice paper that tells the story of this project, and which is available upon request. By the way, each of those case studies and others are available upon request. So this health and safety case study basically demonstrated not only the simplicity of the PEG installation, but also the safety aspect of installing the PEG. And this is also, of course, is related to low CAPEX, where there's not a lot of safety issues and preparation required for PEG. For the next slide, I will hand over the microphone to a customer, to Herman from Volta Solar, to present how the PEG was implemented in the Netherlands and the value of the PEG in the project in Netherlands. So Herman, the stage is yours.
Yeah, hello all. My name is Herman Gouwloos. I'm tender EPC manager at Volta Solar in the Netherlands, and I want to share some experience we have with the PEG system with some project in the Netherlands. We use the project of the PEG system for some project. I think now installed around 60 to 80 megawatts a year. Most of the systems we mounted are with the PEG system itself. We now installed on more than 17 sites the PEG system in a total of more than 40 megawatts already, all based on the east-west system. The thing that is very important for us, that it's only penetrating the underground for about 1.6 feet, because in the Netherlands we are not always allowed to get deeper into the ground with the penetration of the ground, because then always investigation of historical finds has to be provided. So that's always an issue in the Netherlands, and with standard ramming system we always have to do such an investigation. Further, we also use the PEG, so you see in the right bottom corner on some landfills. This is a landfill that we are now commissioning at this moment. I think it will be live on the end of this week, so maybe tomorrow. From 12 megawatts east-west with a PEG system, only penetrating 1.6 feet into the ground to protect also the landfill. So therefore was only PEG feasible to get it on this project. And also what Neil also already mentioned in his earlier sheets, that it is covering the land for over 95% in this case. And that's also for a lot of benefits of the investor. Another thing that we like on the PEG system is the photo on the right top, that you can fill it in within the smallest gaps possible. And what you also see in the picture, it is very easy to add into the ground. And you can make very different figures if the landscape requires. And so also what Neer already told in an earlier sheet, that the landscape has not to be totally square or doesn't need to be hectares large. You can also add it in smaller fields in different shapes. I think the PEG system, what we use, we are happy to use the PEG system, and we are still now trying to get more PEG used than the standard ramming system, because we think also cost-wise as EPCer and also in O&M, we see a lot of benefits in the use of the PEG system. So therefore, we also encourage the innovation that the PEG system has and still is developing, and also the cooperation with Jurchen Technology is great, and we are very happy with it. Back to you, Neil.
Thank you very much, Herman. Just to summarize what we've discussed in this presentation, what I'm hoping that all of you would remember. The PEG system is a very unique design that offers extremely effective land use. I didn't really mention the value, but the value that you could remember is around 700 kilowatt peak per acre. This is far more than what other system would use. In terms of yield, it's around 225 more for a given acre versus other system. Also in LCOE, the system is very competitive, and the reason is the extremely low CAPEX related to the PEG for both the supply and installation. Also a simpler permitting process due to the low profile and the shallow foundation, which, as Herman mentioned, was also key in Netherlands. Online, you can find a lot of material about the PEG, about the design, data sheet, case studies, a project list worldwide, a bankability report. You're welcome to look at our website and to read more about the system. So basically, that's it. Thank you very much for listening. Tim, back to you.
All right, guys, thank you very much for that presentation. And I guess we will just flip it over to the questions here. If everybody's ready to do so, I don't see why we wouldn't be. And so our first question here is, how would the east-west system design with very dense installation impact the general albedo throughout the design?
This is clearly related to, usually I'm asked this question in the context of bifacial modules, that were introduced last year or so to the market. The PEG does clearly have less value with regards to bifacial module compared to other systems. I would just say that the gap between the module is not so small as people might imagine. There's around between 50 to 60 millimeter gap in both directions that allows sunlight to penetrate to the other part, to the lower part of the structure. We haven't really analyzed that into deep details, and actually I'm also struggling to understand the true value of that on other systems, not necessarily PEG. I would certainly say that the value is less versus other systems. However, there is some benefit for bifacial module with PEG as well. We haven't really explored that, and clearly no PEG system was installed yet with bifacial modules.
Can I interrupt you a little bit, Neer, because we are going to install a PEG system for a client of 4 megawatt with bifacial, starting up, I think, in week 37, delivered in week 48. So we are also keen to look at the results of bifacials on PEG. I agree that the influence will be not that great, but we are going to test it on a field from 4 megawatt.
Breaking news. So we have another question here, and it's, assuming an identical surface area, what is the energy to grid difference between the PEG and a single axis tracker system?
Sorry, again, this, assuming the same surface area, I think this is basically what I've mentioned.
Yeah, like the same module surface area, assuming, yeah.
Basically, this what was presented in the benefit slide. If you would take the combination of both, the DC size land use of PEG versus tracker is around 3 times more. But then if you would reduce from that the fact that tracker is more efficient in terms of kilowatt hour per kilowatt peak, then you will end up with around 2.2, 2.4 more energy per land, per acre, per hectare of PEG versus tracker. That changes a bit depending on the location. Roughly, the closer you are to the equator, the distance, the gap is smaller in terms of yield, and the value in terms of yield per acre is larger, PEG versus tracker. But roughly, that's the number, around 2.2, 2.3 more energy per acre from PEG versus tracker system.
Cool. Okay. We have one question here saying that the PV module industry has departed from historical standard sizes for 72 cell modules. The trend is larger and with various form factors. They would like to know how flexible the PEG system is to allow for reconfiguration for larger and non-standard modules.
Well, there's not really a reconfiguration which is required. We are aware of all those 500 plus modules and even 600 that are now introduced into the market. We are in close contact with most large manufacturer of a module of the modules. I would say that the first large module of 42440 from Jinko, the 70L4, was already approved for the use of with the PEG system for a project, for a 20 megawatt project in Asia. A letter being issued by the module manufacturer to the customer, so that we already have a first proof that those systems can be installed with PEG. And I'm talking about a module which is a bit more than 2.2 meter long and 1.1 meter wide. Most new modules are more or less at this range. 2.2 plus long and 2.1 something wide. So the first one already approved, and I would guess the additional one will be added in the near future, also partly based on customers' inquiries and demand.
Mm-hmm. We have a litany of questions here asking about how the system could be used and if it's applicable on a rolling, non-flat, or angled landscape.
So non-flat, what we call is undulated land, where the land is uneven. There are a few aspects to address that. Of course, one is to do a bit of a leveling of the land. That's always, let's say, the worst case scenario. Even before that, what we find out worldwide is that the extremely effective land use of PEG basically mean that if you have an X amount of acre available and you initially consider to use tracker, with PEG you need around 1/3 or half of that land. And then you can fine tune the location of the PEG system on specific section of the land that doesn't require earthworks. So that's another way to deal with this. If you have to install the PEG on a land which is undulated and uneven, there's a bit of flexibility to that. We typically allow around 20 centimeter over 40 meter of land to be the ideal flatness of the land. However, we've been dealing with a land that is undulating way more than this, and the solution is simply by sourcing a bit longer rods in order to make sure that the rod can be rammed to the required depth underground and still have the same height above ground. We're actually dealing with few customers exactly for that these days, and they would source rods that are a bit longer to deal with this for their site.
Mm-hmm. Thank you for that. I have a question here for Herman. It is, what is Volta's preferred approach to under-array vegetation management with PEG installations?
Yeah, we have some experience already with vegetation under the PEG system. But Dutch law doesn't allow us to put a foil under the panel, so we need to do it with vegetation. What we see with vegetation in O&M, that it is depending on soil of the growth of vegetation. So sometimes we don't do any maintenance under the panels because the vegetation is coming up, but not that high that it is causing shading on the panels. And we only do some mowing works around the PEG blocks. And in some areas where the vegetation is higher, we use the mower robot to do the mowing underneath the panels.
I think this one might be able to be answered by either of you, but maybe it's a little bit more directed towards Nir. Someone was asking kind of what the minimum size project for a PEG system would be, kind of the minimum project size threshold to utilize the system in terms of capacity.
Well, I would say, yeah, I would say that interestingly, historically, the PEG system started by 10 by 10 meter system that was designed to address German government law that provided some incentive for private solar system. And then our R&D, Electric Jurchen Technology R&D, came up with this innovative design that was then scaled up significantly to a megawatt scale when we realized this is actually a great design for far larger projects. So potentially there's no minimum scale, even in terms of mechanical strength. A standard block could be 24 modules, maybe 6x4, and that will be strong enough for any application. Clearly, in terms of supply, a single container would carry around 800 kilowatt peak of a substructure to make it more efficient in terms of freight. But practically, there's no minimum. A customer can implement huge amount of small project with the PEG system with no problem.
Mm-hmm. Mm-hmm. Okay, here's another question that we've been asked a couple times in various forms. It is how the PEG system would deal with prolonged, snow on top of it, because it seems like there's no gap for snow to slide down and off. So is it basically a matter of waiting for it to melt, or how would you deal with prolonged snow load?
Well, that's historically, I mean, so far we haven't dealt with a huge amount of snow with PEG. Weirdly, this is not a key concern to quite a few of our customers in Northeast US for a few reasons. Some of them are telling us that they don't really bother because in those periods where the snowstorms and a bit after the snowstorm, the irradiation is anyway very low. Other might have an idea to remove the snow if required. There is a gap again between the models. It is true that the snow itself cannot be removed because it will be sitting on the valley of the PEG system until it is melted. But again, we find customer to be a bit ease with this, with their concern what will be the impact of the overall performance of the PEG. Clearly, this is relevant only for the winter month where the irradiation anyway is not so high. I think as project will evolve, more and more project will evolve in this section of this part of USA, we will eventually find a solution how to remove the snow, which will be done at times where it's worthwhile doing that versus just keeping the snow laid on the modules, similar to how soiling is dealt with in different sites where there's a lot of soiling during the high summer period, which is a way bigger concern than snow over the winter period when there's not a lot of radiation.
Mm-hmm. Mm-hmm. And this is another question that we've been asked a couple of times in different forms. And it was if you have any experience or have heard of any of your projects using, rather than the mower device, sheep or miniature sheep for vegetation management. And I guess that could go to either of you.
Yeah, the concept of sheep is I think it's nice photos with solar and sheep and sort of multiple use of the same land. We and also quite a few of our customers not really in favor of this solution, because I'm told that in Australia, by the way, even sheep would damage cables, not only goats. You know, a solar system is although it's quiet and doesn't move and doesn't pollute, it is a live system, and animals should not be let inside the system. Actually, the PEG offer far better solution for land use for in that regard, is simply by the fact that by far higher land use ratio with PEG versus other system, the PEG can be installed on some section of the land which will be fenced out, and the remaining of the land will be used for farming, for sheep, for goats, whatever. We are not in favor of use of, as well as our customer, again, not in favor of use of sheep or goats within the DC plant. And certainly this is not practical with PEG because of the very high land use.
We had another question here. If you have any experience with PEG in flood zones of up to 2 feet?
Not yet. There are customers that looked at the system in tropical Australia, which is where they thought about implementing the PEG to a height of around 1.3, 1.4 meter above ground, so around more than 4 feet. That project was not implemented eventually. It was a bit, I think it was not eventually financially viable. Theoretically, it is possible. You just apply a longer rod, especially if the site, its wind load is not so high. However, we don't have any project yet where the PEG was used for such a site.
Someone here was asking if you've tested the performance, the production performance of the system in North Arizona, or if your data from Australia would be comparable to what would be seen in Northern Arizona.
The PEG system was installed in harsh desert areas in a few locations in the world. A few of them is in North Queensland, which is extremely hot and sunny. I would guess not too far from the weather you would find in Arizona. The performance of the PEG was carefully tested as part of the bankability report, which we can share. I don't see any issue of performance of PEG in any climate. We actually have the PEG installed in Europe, in moderate climate, in desert, in snow now, in Austria recently, also in moderate climates, not only Europe, but also in Australia. I don't see any problem with performance of that system in any climate.
Cool. We are getting a little bit close on time here, but I think we should have enough time for a couple more questions. One here is how do project designers or developers treat soiling, and what kind of increased cleaning is needed to support high soiling assumptions?
It is very different per project. The most surprising answer, I would say, that most of our projects in Australia since 2017, most of them were not cleaned to date. Well, customer told us that even in relatively desert areas in Australia, the weather regime was not so severe in terms of dust storm versus occasions of rain that didn't require cleaning, which was a bit of a surprise for me, but that's a fact. I've been told by all customers the same answer. The same in Europe. We have developed this gal-in system, which is in use in Israel, especially during the summer period, more or less now, and recently been used by a customer in Australia. We do look at the robotic system that will be used. So we keep on developing the cleaning system, basically disregarding the fact that for somehow during the last 2 or 3 years, companies found soiling not to be a big issue as they thought initially. So we have a solution, whether this is the manual one, which is already available, and the robotic solution, which will be available during next year.
All right, I think we have time for one last question here, and I think it's a good one to end on. They want to know how the strength of the metal holds up over the lifetime of the project, and just, any information on, the lifetime of the metal and how it holds up in terms of strength.
Well, first of all, the substructure is extremely robust. We have certified the system in an environment that were a bit acidic in terms of the soil corrosion. There's a corrosion thickness of around 70 microns on the rods, around 20-25 on the plates. We dealt with third parties, engineering firms, to confirm soiling and different, corrosion protection and the system rust over the project life. Clearly, from pure engineering perspective, there's always a project engineering and calculation, static calculation, which is done for the project. A different aspect of the mechanical aspect of the PEG design was heavily discussed in the bankability report, and I encourage everyone asking this question to have a look at the bankability report. We run multiple studies. Also, the wind tunnel tests help us confirm the strength of the system. We provide a warranty, by default 10 years, but we can extend that far more if required by customers. And that's all being dealt per project, and we're comfortable and confident that the project would, that the system would last for 30 years or even far more, 30, 40 years, no problem.
Cool. All right. I think that about wraps up the time that we have here today. I would like to thank you both for this presentation and for sticking around, being able to answer these questions. For people who may not have had their questions answered, and I know there was another thing brought up, we will be sending any pressing unanswered questions along, and also there are recordings of this presentation that will be made available later. But don't go anywhere just yet, because PV Magazine has some exciting webinars coming up in the future. On the 3rd of September, we have GE entering the Australian residential solar segment. And on the 24th of September, we have Back Contact move to the front. If you ever want to know anything more about our upcoming webinars, who we partner with, what time they are for you, anything, just go to pvmagazine.com/webinars. You can see us circling it right there with the cursor. How about that for presentation value? And I would like to thank also everybody who attended this webinar. Have a wonderful day, night, whatever time it is where you are. I hope it's wonderful.